Contest 1, problem 7. Okay. So this is the one. We're looking at this. Okay. So one person managed to solve this. And also, if we're on a problem that you've solved correctly and everything, go ahead and work on another problem. Or, because I don't think any of us have finished all 10 of the DMOS problems that I assigned over those 2 weeks. But yeah, okay, so let's get started. With expert advertising from John, Williams' band concert is sure to be a huge success. But just be sure William looked to hire another performer to come to the concert in order to maximize his possible revenue. William ends up hiring Victor, the greatest circus clown in all of Russia, apparently. This guy, Victor, is looking to expand his repertoire of tricks, though. Most of the performances to date have been really lame. Fortunately, William's got an idea. Everyone loves a nice tightrope performance, but Victor's not so sure since he has incredibly poor balance. William knows how to solve this issue, though. Just attach weights on either side of Victor to ensure that he is as balanced as possible. To help William, this was spelled wrong, but that's okay. William and Victor avoid going through all the work of trial and error, code a program that, given a number of weights of different weights, and we'll split these weights as evenly as possible into 2 different groups. And no, you cannot just put no weights in both groups. For the input, the first line will contain a single integer t. The next line will contain t space separated integers. Output an integer representing the minimum difference that can be obtained by putting the space-separated integers into 2 arrays and finding the difference between the sums of the 2 arrays. Okay, so you're given the sample input, and then you're given these 22 numbers, and you have to find the minimum difference by splitting them into 2 groups. Okay, so we have to do something to make it, we have to do as much as we can to optimize this. Although most people, I don't know if the data was exploited and it could be solved in a really fast method. That was like a basic recursion. We're going to go through the actual proper way into solving this. So
it was the constraints that screwed people over.
Yeah, but Yang learned from Contest 1 and made Contest 2 very great. So we're going to go ahead and move our whiteboard to the right when that computer responds. Okay. Now that we're good to go. Okay, this is actually very annoying. Let me just create a new whiteboard. As you can tell, I love using Microsoft Whiteboard because it's great. Alright, so we have n, we have t weights, and then input all weights. So that's the order of the sample input. Okay, so let's say okay, so let's say you have an array with some tot. Let's say tot was a sum of all the elements in the array. And then you split the array into 2 sets, or into 2 separate arrays. S1 and S2. Just 2 random arrays with some contents. And then and then this one has a sum of tot 1, and this one has a sum of all elements of tot 2. Okay, so since we're looking for a total sum of tot, what do we know? What can we relate with tot 1 and tot 2 and tot? Because all the elements in the array were either put into the left, into the first array, or the second. What do we know about the sums? Okay, let's start calling out people. Okay, Andy.
Wait.
Okay, actually, Brandon, go ahead.
Or not? Okay.
I said go ahead, Brianna.
Oh, okay, sorry. Okay. You want them to be as close as possible?
Yeah, but how can we relate tot 1, tot 2, and tot? Is what the question's asking.
You want them to be as close to the half of tot?
Yeah, that's the goal.
Okay.
That's the goal. We want to be closest to half tot. That's a good thing to notice. But okay, let's just go to the next person. Eston, what do you know about the relationship between tot 1, tot 2, and tot? If for any way you split the array.
Well, tot 1 plus tot 2 gives you tot?
Yes.
Yeah.
Tot 1 plus tot 2 equals tot. Okay, so that's just saying the sum of the elements in the first array, and you add on the sum of the elements in the second part of the array, and that's equal to the sum of the elements of the entire array, the original array. And that's obviously true because you've either put all the each of the elements was either put into one or the other. Okay. Okay, so we have tot 1 plus tot 2 equals tot. And then we need to manipulate this somehow to give us a discrete answer, given the fact that we found that one sum exists. So that probably sounded like complete.
Is she cutting out?
That's a good question. Am I cutting out?
Yeah, he cut out a bit, but it's good now.
Okay. Let's just hope that doesn't happen again. Alright, so the answer that we're trying to look for is the minimum difference between tot 1 and tot 2. And so we have to do something to relate. We should use this equation to try to relate tot 1, the difference between tot 1 and tot 2, the absolute value difference. We want to relate it to tot somehow. So what can I add to any number in the world such that it won't change the value of that number? Who's next? Evan.
What?
What number can I add to any number of the world such that it doesn't change the value?
0.
Yeah, okay. So I'm going to do it as tot 1 minus tot 2 plus, and then I'm going to write 0 as something wacky. I'm going to write it as a subtraction statement. I'm going to write it as tot 1 minus tot 1. Actually, no. I'm going to write it as tot 2 minus tot 2. Either way will work. You're going to get the same idea. And then, so instead of just canceling these out, because then if I cancel this one and this one out, it wouldn't have any purpose. So, because like that would have done literally nothing for us. So let's combine these two terms and these two terms. So we have tot 1 plus tot 2 minus, and then minus tot 2 and minus tot 2 make minus 2 tot 2. Okay, and I've put this in brackets for a reason. Who's next in line? Gordon. Why did I put this in brackets? What can I do with it?
that is equal to tot.
Yes. It's equal to tot minus 2 tot 2. Okay, so let's think about what we've done here. The desired thing that we were looking for was the absolute value, value of the difference between the two subarray sums. And we've, throughout some process of adding 0, rearranging, and then combining, we set that equal to the absolute value of tot minus 2 times one of the subarray sums. And so our final answer, what we want to do is, our goal, output the minimum value that we have of tot minus 2 times tot 2. So if we're able to find the lowest, if we're able to find some tot 2 such that the difference between tot and 2 tot 2 is minimized, that will be our answer to go for. But now we could find tot really easily. It's just the sum of all elements in the array. But as Brianna said, 2 times tot 2, we want the sum of each of the things to be as closest to half tot as possible. And why that makes sense over here is if tot 2 was exactly 1/2 tot, then this absolute value difference becomes tot minus 2 times 1/2 tot, which is tot minus tot, which is 0. And the absolute value is 0, 0. So that would be our minimal answer. So we want tot 2 to be as closest to the minimal we want the difference to be minimized, and by doing that, we just want the total sum to be as closest to 1/2 tot as possible. And know that the distance between tot 2 to 1/2 tot will be the same as the distance between tot 1 minus 1/2 tot. Because their sum is tot, and the sum of these two is tot. Or in other words, the average of tot 1 and tot 2, oh, that looks really bad, is 1/2 of tot. So they're both going to be the same different distance away. So these are all these are things that you need to realize later on. I mean, they're all going to fit together in pieces as you try to solve the problem. Okay, so now comes, so we've simplified the problem to finding the subarray, the difference between two subarray sums to the total sum minus 2 times the one of the subarray sums. So now we've essentially reduced the problem to find a subarray with sum closest to tot 2. No. Subarray with sum closest to 1/2 tot. So if we're able, instead of necessarily trying to directly find, like trying to use some searching thing to find the best sum to 1/2 tot, and going through all the elements and trying to do some adding and subtracting, that's not necessarily going to work, or if it works, it'll be really slow. So what we can do is generate an array with all possible subarray sums. We want to create some array. In the end, there should be some array that will have all the possible subarray sums. And the way we're going to do this is we're going to have a 2D array where it gets very similar to knapsack at this point, where you have a Okay, you have, let's say you have I and J. Let's say we call it dp. dp I of j will hold whether you can create a sum of j using the first I elements. Okay, and then the relationship between dp I of j and something else is actually very simple. There are two cases. dp of I of j is true when the first case is if dp of I minus 1, so using all elements except the current element you're considering, and a sum of j is true. So if you could create a sum of j using the first I minus 1 elements, then you don't have to insert that element into this, because it's already been cleared that you can create a total sum of j using the first I minus 1 elements, so it's obviously true that just not inserting it will make a sum of j using the first I elements, just not actually adding the ith element into the subarray. So, and then the second case is if dp at I minus 1, and then this is similar to knapsack, j minus array at j minus array at I, where array is the total number of the different weights. Because this is saying we're going back up from I to I minus 1, saying we're not considering the current element, and we're going back the weight of the current element, j minus array of I. And if that is true, then that means we can take this current element, which has a weight of array of I, and then therefore with the first I elements you can definitely create a sum of j. So it's, if either of these cases are true, then dp of I of j's will always be true. Anyone have any questions up until this point? Okay, if not, we'll go ahead and implement it. Alright, so have I been cutting out a lot, or have I been mostly clear now?
You just cut out a little bit, but you've mostly been clear.
Okay, so you've been able to understand what I said. Alright, so the maximum number of elements was 10,000, as said by all constraints over here. So I'd like to create a constant variable holding the max size, and then making it slightly bigger than 10,000. So I needed a array of all the elements, and then I needed the total number of I need my dp array. Max t times, and since all the numbers are between 10,000 and 10,000, then that means that we have max t times max t as our second size. But hold on. Looking at the memory constraints, what was it again? memory limit was so 131 MB. So basically 128 megabytes.
128 megabytes.
Yeah. Max T times max T times another dimension max T gives a lot of bytes, way more than 128 megabytes. So what we're going to do is using a similar tactic as to what we did last time was having a DP old and a DP new. And if you don't remember, it's just this is your old array, and then so what happens here is DP of I will be DP of I is just DP new, and then DP of I minus 1 is DP of old. Oh, no. DP of old. And then once you go through and you completely assign all your new values, you set all elements in DP old equal to DP new. Okay. So, we're gonna use it like that, and so we're actually gonna take our input now. So int t, take in our input t, and then now we need to take in all elements. And since we're going like we're working with the first I element, then we should probably just keep DP of 0 as an empty array, just so that we're continuing the same logic of working with the first 0 elements, then working with the first 1 elements, and then working with the first 2 elements. So what I'm getting at here is we should probably be one indexing our array. Okay. So, CNT, and so since we're one indexing our array, for int I equals 1, I is less than or equal to t, I plus plus, cn, taking our input, cn, array at I. And then since we need the total sum stored somewhere, we should probably have int tot equals 0, and then saying tot plus or equals array of I. Okay. So now tot will at this point be the sum of all elements, and then your array is going to have all the values. All right. So now we need to loop through and fill in DP array, kind of like knapsack. So we need to loop through all the indexes from 1 to t, because that's the total number of elements. And remember, by default,
I have a
question?
Yeah, shouldn't it be max t times max t for the DP arrays?
Yeah, you got a good point. They should be max t times max t. And the reason that it should be max t times max t, Kevin, do you want to explain?
Is because you can have 10,000 elements, and then they could all be up to 10,000. So the maximum sum is 10,000 times 10,000.
Yeah. So if each of the numbers can be between 1 and 10,000, there's 10,000 of them, then it should be 10,000 times 10,000. Or in other words, close to max t times max t, which is what we're going to use. Okay. So let's go ahead and fill this in. So for int I equals 1, I is less than or equal to t, I plus plus. And now we need to loop through the total sum. So for int I equals, and we can actually use 0 because there might be something with a weight of 0. Is there or is there not? I can't remember. Okay, so they're not. All right, so we'll just loop through 0 anyways. It can't hurt. Int j equals 0. Can't use it. Don't want to use the same variable. That's gonna hurt. J is less than or equal to tot, which is a total sum, j plus plus, and then we're gonna go dp I of j is equal to, actually, what am I saying? They should have been Booleans. Oh wait, so we need to check. So first what we can do is just say dp I of j, no, not dp I of j, I'm thinking this is a 2D dp, right? dp new of j equals dp old of j. So if dp old of j was already true, then we don't need to actually do anything with it. But we'll just keep it there anyways. And now we have to check if j minus array of I is greater than or equal to 0. So we're checking if we can go back array of I. Like if we can go back the weight of the current item and we're not going to be at a negative value. And then if so, then we can say dp new of j equals dp of j minus array of I. No, dp old j minus array of I. But we don't need to necessarily do this if dp new of j is already true because of the old statement. So dp new of j. So this is saying if dp new of j is not already true, then we can assign it to dp old of j minus array of I. So there's a chance that it will be both be false, or the second will be true, in which dp new of j will be true. And then now to our realization on the whiteboard over here. Where was it? So we need to loop through the total sum. We need to loop through. We need to go from half of the array sum and check all the possible values. Like we need to check if the possible sum was there, and if so, then we could use it. So what we need to do is for int I equals tot over 2, I is greater than or equal to 0, I minus minus. And then, actually, we should have an answer array. Int ans equals, and then we'll set it to int max because we're trying to minimize the difference. Actually, we didn't do something first, but we're gonna get to that. If dp new, we're saying is if the final array, if the final array's values at an index I is true, so you don't have to put equals true. You can say if dp new of I, then the answer is equal to the absolute value of tot minus 2 times I. And then here we're going to break out. And the reason I break out of the for loop over here is if we're trying to get as close to tot over 2 as possible. And if we're starting from tot over 2 and we're going down, working our way down, then if we find at some point that a sum is better, then if we keep going down, we're not going to find a lower difference between the two subarray sums. Like we're not going to find a better difference of tot minus 2 times I. This is just going to keep increasing. So over here we can just print out our answer. And what I failed to do over here was realize that I have to actually assign dp old to dp new. And so just assigning the values, I'll just for loop it. So for int I equals 0, I is less than or equal to tot, I plus plus, dp old, actually no, we have to use j again. Int j equals 0, j is less than or equal to tot, j plus plus, dp old of j equals dp new of j. So what we're doing here is we're setting our old values equal to our new values, so that the next time we loop around, we can have our dp new of j to be, oh wait, I never even recorded. Actually, no, did I record? Oh yeah, I recorded. We can set our old values to our new values, so that when we go loop around next time, the old values are the old values are going to work for the next iteration. So let's give this a shot. Copy this text, paste. Okay. Looks like I completely messed up somewhere. Oh, I know I did wrong. At the start of the program, what I failed to do was assign dp0 equal to true, or dp old of 0 equal to true. And the reason this is important is because if you don't set, this is saying with a total sum of 0, we can just take any amount of elements and we can create a total sum of 0. And that's true because obviously we don't take any elements, our sum is 0. And if we don't do this, then the whole program messes up because we started with a false. So let's try again. 0. So this will pass, I'm pretty sure. So any questions with how I implemented it?
Wouldn't this time limit?
This is O of n squared.
Tot can be, you're looping through t, and which can be up to 10,000 or t, and then tot can be up to t squared. So wouldn't that be O at t cubed? You're looping from I through 1 to t,
okay,
so that's O at t.
Yeah, you're right. This would actually be O of n cubed. But the thing is, you can't really beat this time complexity. So let's just say that the data was wrong, or the total sum was wrong. But you can't beat the total sum times the sum of each element. So the constraint should have been adjusted for that. That is our bad.
Wait, so what is the time complexity for like brute force?
Brute force?
Yeah, if I were to generate all subsets of the array.
2 to the power of 2 to the power of the number of elements.
Oh, would that have passed in C++?
In this specific judge, maybe, I don't know, but in real life, in their other questions like this, no way. Because like imagine like tot was like 30, then it's already 2 to the power of 30 is what? Like it's really big. Yeah, this humongous number. 1,073,000,000,000,
Oh yeah,
740.
I know, but I was just I was just wondering how bad 2 to the n was compared to n cubed.
So yeah, if our constraints were actually the totals, each of the elements were less than t or less than or equal to t, then it would be O of t cubed. But the constraint should have fits so that it gets adjusted so that it matches this. But this is the legitimate way to do it. So I'm gonna copy this and put it in senior chat. I also put it on GitHub, but just in case some people don't feel like going over there to GitHub, then I'll just put it in chat. Okay. Any other questions? Okay, if not, then we'll move on to our next problem. So I'm just gonna comment all this out and move it down. Alright, so we'll skip this for now because it's got, I'm not gonna necessarily we'll go through the entire implementation. Okay, but we'll skip that for now, and I'll go through it towards the end. So next up is Unga Bunga. So that's contest 2, problem 6. Let's close these tabs. Don't know why they're open. Okay, looks like this thing decided to go crazy. All right. Contest 2, problem 6. Wrong question? Did I just choose the wrong question completely? Maybe it was problem 7. Nope, that's the one we just did. Alright, maybe it was contest 1 problem.
I think you're in the wrong contest.
Oh yeah, I am in contest 1. It should be contest 2. Thank you. Alright, contest 2, problem 6. Let's close that. Okay, Unga Bunga time. So, this question says, okay, I do not feel like reading all that. As much as Yang can give a great story, I'm not fully capable of reading that right now, mostly due to my laziness.
Don't worry, I wrote it to force people to I don't know, like it's like Echo, you know, because Echo has a lot of writing.
Okay, but the chances of Echo happening, oh yeah, it actually could happen online this year. Well, we don't know about that. Okay, so input will consist of a single integer t, followed by t lines. Each line will contain 2 space-separated strings, both with length not exceeding 100. The first of these strings will be the incorrect output that Yang's program gives. The output that Yang's program gives out. The second string will be the correct version that Yang will have to change the original into. Output t lines on t, 2 integers on t lines, each representing the minimum number of changes Yang will have to make to change the corresponding input into proper form. And change involves adding any letter, removing any letter, or replacing any letter. Okay. So we're giving this sample input. 2 ostrich, ostentatious, and confucius coniferous. Don't know if I pronounced those right. Hopefully I did. Okay, so let's just take our input first, and then we'll talk about how to solve these. Okay, so int main. Oh yeah, if you don't pass in real life, just for the first problem, just know that I didn't put fast input because I completely forgot. But I don't think you'll have a trouble on the judge. I don't think the contest is open right now. All right, so string s1 s2. Okay. All right, we should put better names because this is actually old string and new string. Okay, so we take in t, then for ints q equals 0, q is less than t, q plus plus, q being, let's just say, a query, but generally a useless variable. And then we have to take in our old string and our new string. Alright, before I get started, I'm actually curious, how many people managed to solve it? 2 people. Alright, so we took in our old string and our new string, and we have to find the minimum number of changes Yang will have to make to change the corresponding input into proper form. Okay. So, this question can get really big. 10,000 by 10,000 by 100. Okay, so let's give this into the whiteboard. Alright, so I hope that no one has any questions about the first problem that we did. I feel like that was well explained, but as always, it's all about your opinion, not mine. So, yeah. Next problem. This problem is string changing, in a sense. String modification. That seems like a better name. String mod. Okay. So take in old string and convert to new string. Okay, so this is actually going to turn out to be a very similar idea to what we did for our previous problem. It's going to involve something like going back and looking at previous values and using them to find current values. So, given two strings, let's say we have, let's actually look at our first sample input. Ostrich, and then we want to go to ostentatious. These are good words. I really don't know if they're fake. But knowing Yang, they're probably not. So we have two words, ostrich and ostentatious. And we have to find the number of changes to go from one to the other. Okay, so the idea of what we're going to do here, the idea of how we're going to implement it is looking at another 2D array. And we're going to use size of new string and then size of old string. Okay, so what we're going to do is try to see if we can relate the number of changes using the number of changes required for a previous set of characters. And so what this represents is, so if we had, actually this should be +1, and this should be +1. So ostrich has 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7. Those numbers got very squeezed very quickly. And so we have 3, 6, 9, 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Forgive my very lackluster diagram. Okay, so we want DP, if we're going to call it DP again, because why not? This is essentially using previous values to calculate new values, so I just like to call it DP. DP of I of j to be minimum number of changes to minimum number of changes required to convert the first I character characters of old string to the first j characters of new string. And then our final answer would be dp of old dot size and new dot size. This is just a rough sketch, so the syntax isn't necessarily correct. The variable names are constantly changing, but I hope the idea is still coming through. All right, so we need some base cases. And for that, we have to think. All right, so who is next? All right, so we have to think about our base cases. Obviously, let's take the size of the old string to be 0. So we're working with the first 0 characters.
Oh, you're cutting out a bit.
He just died. Hope he's alive now.
Okay, maybe it's because I talk too fast or I keep making changes and it goes crazy. Alright, so let's say I'm working with the first 0 characters of the old string and the first 0 characters of the new string. Who is next? Ingrid, how many changes would I have to make to the old string to convert the first 0 characters of the old string into the first 0 characters of the new string?
0.
Yes. Okay, and while you're still here, the first 0 characters of the old string to the first 1 character of the new string.
1.
Yeah, 1. And then this one?
2.
Okay, so now we see the pattern. So the amount, you just have to keep adding characters if we're going from from no old characters to some amount of new characters. So this is just 0 from 0 old characters to 0 new characters, 0 from 0 old characters to 1 old new character. One of the new characters is just adding the first character. Then from 0 to 2, you're adding the first 2 characters, then the first 3 characters, and so on. So this gets filled in like so. And then looking down on this column over here, working with the first 0 characters of the new string, to get from the first something characters of the old string to 0 characters of the new string. Who's next? Kevin. To get from 1 character of the old string
Hi.
to 0 characters of the new string, how many changes do I have to make?
You have 1 change.
And what is that change?
You remove it.
Remove it. And then for 2 to 0?
You remove 2.
Okay.
Or you just remove both of them.
Yeah.
And so on.
Yeah, so
And
you have
so
the idea.
forth. Just put ...
I kind of want to fill in the table somewhat. Alright, so thank you, Kevin. So we've filled in our base cases. So dp of 0, so what we see is dp of 0 of I was 0, and dp of I 0 was 0. Those are 2 things that we've assigned as our quote-unquote base cases so far. Okay.
Don't you mean equals I?
Oh, yeah, equals I. What am I even saying? Thank you, Kevin. Equals I. Because we need to make I changes to go from no characters to I characters, or from I characters to no characters. I have no idea what I was thinking. Okay, so, now we need to work with a general dp I of j. Actually, let's go more to the right. Alright, so if the ith character of old was the same as the jth character, we're trying to build it up using like the similar strategy with what we did with our first problem and like knapsack. So if we're working from the ith character of the old string and it was the same as the jth character of the new string, then what can we conclude about dp I of j? Who's next? Lily.
What was the question?
If the ith character of the old string is the same as the jth character of the new string, what is dp I of j equal to?
dp I minus 1, j minus 1?
Yes. dp I minus 1, j minus 1. That does look like an exclamation mark. dp I minus 1, j minus 1 equals dp of ij. Because we're saying that we don't need to make any changes. We don't need to add on any changes considering one character back, one less character from the old string and one less character from the new string. Like, we don't need to make any changes to make the string with from the first I characters of the old string to the first J characters in the new string. So that's our first case. And our second case, otherwise, dp of ij is, I'll just go ahead and fill this in. We need to add one to the minimum of, we either add a character, so we're going dp I minus 1, or not adding a character, dp of I minus 1 j minus 1 plus 1. This is saying we're looking at the I minus 1 and the j minus 1, and we're adding on one more change because we're changing the ith character of the new string into the j of the old string into the jth character of the new string. So we're adding on a changing thing, like a changing value. And then our second thing we write here is dp of I of j minus 1 plus 1. And our third thing, I'm going to explain in 1 second, of I minus 1 j plus 1. So it's the minimum of these three things. These two represent adding or removing a character, because we're considering the first j minus 1 characters and the first I characters. So we're just going to slip in the jth character of the new string, and here we're going to slip in the ith character of the old string. So this is our way of computing dpi of j. So it's the minimum of, this is change, and this is add to new, and this is add to old.
It's not just you, Evan.
Oh, am I cutting out?
Okay. Oh, you're good now.
Oh gosh. Okay, so it's just gonna keep going back and forth. All right. So does anyone have any questions with how I assign dpi of j? And keep in mind, this is all happening because the ith character, or this is all happening because that is not true. Okay, so and then obviously I and j, we're going from going up to size of old string, and then j is going to size of new string. Okay, so let's go ahead and implement this. So we've taken in our old and new strings, and the size of the strings are at most 100. So let's create a dp array with just like 105. Just give a slight amount of headroom. Okay, so we took in our old and new string. Let's just do for ins I equals 0, I is less than, oops, 105 I plus plus. And so now I'm assigning base cases. And that was dp0 of I equals dp I of 0, which is I. This is the same as assigning each of them to I, but I'm just doing it all in one line. Okay. And now from here we go for int I equals 1, I is less than or equal to the size of the old string, and this is done by old string dot size I plus plus. And then similarly, looping through the characters from 1 to, or the indexes from 1 to the new string size. Oops. And now we need to do our quote unquote knapsack, which is not really knapsack, but sure. Only problem is old string and new string, these are 0 indexed because strings are 0 indexed, and our arrays, since I'm going for the amount of characters used, these are 1 indexed. So instead of using the ith character and the jth character, like the logic is still going to stay the same, but I have to index with I minus 1 because the indexing is 1 different. So if the ith character of the old string is the jth character of the new string, then dp I of j equals dp of I minus 1, j minus 1. Otherwise, dp I of j equals minimum of, and the problem with C++ is, or a weird thing with C++ is you can only pass in 2 things for your minimum. So we're just going to create 2 minimum things, the minimum of 2 things, and then the minimum, comma, the third thing, and we're going to take the minimum of all those. Will give us the minimum of all 3 things. So dp of I minus 1, j minus 1, plus 1, quantity minimum of dp of I minus 1, j plus 1, comma, just move that to the side, dp I j minus 1 plus 1. Okay. So that's just underlined for no reason. And that should be good. We just need to print out our final answer. dp of the final answer is dp of old string dot size and new string dot size. Okay, so let's give this a run. This is all commented. Okay, this is taking a while. Let's just reload. It's taking our data while we're waiting. Copy and paste. It's taking a very long time to build. Okay.
Feels bad, man.
Yeah, because my code just went away. It didn't even save. That's great. Let me just type this again real quick.
That's why you have to not use replit.
No, that's why you have
And
to
also,
have,
you should have done that like copy paste.
Pardon?
What?
Oh, you should have copy pasted so you don't lose your code.
But I was copy pasting the data.
That's true. Or we can copy paste the data later.
Oh yeah, I have clipboard history on.
Are you still on someone else's computer?
I will be for like the next few months. As you can see, my background has not changed. Quick glance. I hope our the person who will be editing this video has fun. Alright. Yeah, actually, I have clipboard history on, so let me just actually copy it. Now let me copy the data. Okay. Well, maybe I should actually print it out here. That would be better. Ten and 6. Not what I wanted.
Is this supposed to be old Strua at I minus 1 equals new Strua at j?
-1. Yeah, you got me there.
Okay.
Yeah, I literally said it myself, and then I ended up regretting it. All right, 8 and 4. Is that your final answer? Yes.
Or maybe it just didn't.
All right, so we'll just put our fast input code just so it doesn't mess up the formatting like that. All right, and speaking of output, one of my good buddies, I don't know if he wants to mention his name, probably mention his name later on, or if he wants to shout it out. He was doing a problem. He was doing a problem, and he had an issue with TLEing, and what actually ended up happening was, you guys probably have noticed that I use \n as my output thing for pretty much all the things. Like, I don't remember using endl, or I probably just use it when I'm too lazy to use the quotation marks. But this guy, he submitted a problem with endl, and because he was using sin.sync with stdio and sin.tie0, and then he was using endl, the endl flushing the output made it really slow. So when he switched to using \n, it made a huge difference, and he AC'd the problem. Summary is, I recommend that you guys just always switch to using \n, because I never thought I'd see a day where it actually mattered if you use \n or endl. I just use \n just to flex that I was 0.01 seconds faster than other people. But yeah, I recommend that you guys all use \n instead of endl, because they're essentially the same thing. It's not that much more typing, but it's worth not TLEing on a problem that you shouldn't TLE on. Okay, speaking of, so moving on from that, so anyone have any questions with how I implemented this string changing problem? Okay, if not, I'll paste this code and I'll comment it as well. So I'll post it on GitHub after.
Well, should it be bigger than the word limit?
Well, the other one wasn't bigger than the word limit, so there's no way this one would be. Because it felt smaller to me. Or it's probably because the concept was very similar and I thought it was a lot less code. Alright, so those are the first two problems that we've taken up. Now the third problem that we're going to look at is post-dramatic, contest 2, problem 1. Okay, so how frequently have I been cutting out? And how bad is it?
Not that much.
That's good to hear.
Stress disorder.
Yes, stress disorder. All right. So, this question is touching on I'd say it's in between graph theory and dynamic programming. It's a good crossover, and so is our next problem, I think. And we'll be after Christmas break, we'll be doing a bunch of graph theory stuff because I feel like I want to get dash structures out of the way. And for the CCC, you don't have to know too much of dash of graph theory, but dash structures, historically, they've had problems that were very trivial if you knew the dash structure to use. Okay, so post-dramatic. First line input will contain a single integer t between 0 and 101. T lines will follow, each with two space-separated integers a and b both greater than 0, less than 1001. These represent a path from city A to city B that will take 1 day to traverse. These paths will also work in reverse, meaning that a path from A to B also represents a path from B to A. It is not guaranteed that paths will only be listed once. There may also be more than one distinct path from one city to another. Finally, there will be two space-separated integers s and e both being greater than 0 and less than 1001. That will represent the city where Yang's package is currently located and the city that Yang lives in respectively. I will put the maximum number of days that Yang will have to wait. It is guaranteed that there will be a valid pathway taking more than 0 days. Okay, so give me 1 second. I need to drink some water. All right. Thank you for waiting. So we need to find the maximum path length between between the start and end, and the distance or the time length is also the number of nodes or the number of edges you go through, because 1 day is 1 node, or 1 edge. All right. So let's first take our input, and then we'll discuss how we want to approach this. So first line is t, which is the number of, nope, not trap trace, don't know what that is. Then t lines will follow, each with two space separated integers a and b. And then after the start and ending. Okay, so this seems like I want to use some sort of graph and recursion to solve. So I'm going to make these variables quote-unquote global, aka outside of int main, so I can use them in a potential function that I'm going to make. Which I don't know if I want to make another function, but I'll definitely be finding out soon. There's no reason that there's no downfall of me doing it. Okay, so constant int max. Alright, so the city, there's at most 1001. So constant int max size is 1000, and let's just go 1005. And so what I'm going to do is, to create a graph, I'm going to do vector of an integer vector called graph, and I'm going to make its size max size. So what this is going to look like is graph at 0 is going to be a vector, graph at 1 is going to be a vector, graph at 2 is going to be a vector. So there's going to be 1005 vectors that are initially empty. That's how. That's why I emphasize in the first week, I believe, that when you have square brackets, it's after the end, it's always going to create an array of anything that you have inside, or anything that you have to the left. So we have a vector. Now we're going to have an array of vectors, and that's what we're going to use. So first we're going to take, and then now we have our a and b our starting and ending points. So we have, and so there's t edges, or t paths. So for int I equals 0, I is less than t, I plus plus, c in a and b, taking our two cities. And then what I'm going to do, what this graph is going to be is, for every index, it will hold a vector of all cities it is connected to. So because the question specified that the paths are bidirectional, I need to add A to B's graph and B to A's graph. So what this means is, let me just type it first and I'll explain. Graph B dot pushback A. So what I'm doing here is I'm taking my graph at A is the cities that A is connected to, and I'm adding B to that list of connected cities. And then graph at B is the B cities that I'm connected to. Out of all cities I'm connected to from B, I'm going to add A to those connected to those list of to those vector of connected cities. And then after, we need to have our start and end points. And because I think I'm getting more and more convinced that I'm going to actually use a function, let me just create a start and end outside so I can use it globally, quote unquote globally, and take in the start and end. So I need the longest time that Yang will have to wait. Okay, so the way that I think I'm going to approach this is by having some sort of array. Actually, let me just type this. Strategy. Have some sort of array. Having some sort of Boolean array. Let's be more specific. Holding whether I have visited a current, have visited a node. So what this will do is prevent any node from going somewhere twice, or any node from being accessed twice in the same path. Okay, and then after, I'm gonna have, we also need an answer variable holding the maximum number of nodes to traverse in order to go from start to end. Okay, so I'm going to need some answer variable and max dist. And so before I do anything, I want to make max dist a very low number. Let's make it a negative number because we know a distance can never be negative. And so we want to update dist when we've reached the end. So so obviously going from negative 100,000, you're always going to be able to have a longer distance than negative 100,000 because distance is never negative. So we're good to go. Okay, now comes this function I keep talking about. So what I'm going to do is create a function that reaches out to other nodes and or other cities and tries to find a path to the end. Okay, so we need a void traverse. And then in that function, we need the current node or current city, and then also the distance that we've covered so far. Okay, so when we're in going through our when we're going through and reaching out, trying to find a path, once we're at the endpoint, so if cur city equals E, then this is when we update max dist because we reach the end. And so what we do is max dist is equal to the maximum of max dist, comma dist. And the reason I use dist is because this dist was added on for all the function calls that we have used previously. And what I mean by all the function calls will make sense in just a few more seconds here. So otherwise, we're not at our endpoint. So we need to go through all the cities that we can go from in our current node and try to breach out to them. So so now we need to loop through all of our cities. And instead of doing indexing loop, because this is a vector, I'm just going to do int next city in graph at cur city. Remember, this loop will automatically look through all the different next cities, so I don't have to necessarily index it. So I don't have to index it all because this is a different type of for loop. It's not like looping through the graph city size. It's just looping through all the different elements, and it's just storing them as next city each time. And if you're in your current path and you haven't visited the current node, if not, oh wait, no, I never actually created. All right, so I need to have some sort of Boolean array holding whether I visit a node, and that's where this comes in. I need a Boolean array. So bool viz, let's call it viz, and it's gonna have a size of max as said. If I haven't visited this next node in my current path that I'm going through, keep in mind I keep saying current path I'm going through. In my current path, if I haven't visited the next city I've reached out to, then I want to what was the function called? Traverse. I want to traverse to that city. Next city, comma, and since I've went through my current city, my distance is one more than the current distance. And so when I visit my next city, what I want to do before I get there is just set the viz at next city equal to true, just so that when I go there, I'll know that I can't go back. And then after, when I'm done, when I've traversed there, what's really important here is I need to unflag the viz at next city. And the reason I need to do that is I was only doing this in some current path. If I can get to next city in another path, it's completely valid to visit that city. So I need to set my viz at next city equal to false now. Just so that if I need to, if I find some other path later on in my list of recursive calls that I have here from traverse, then I need to be able to reach that next city because I haven't visited there from a different path. So that's why I make it false after I'm done, because it's just after the recursive call. That means I'm going back and I've validated whether or not I can go to the endpoint, and so I validate whether that path is valid or not. And then after, I need to set it to false just so that I can use that city in another pathway. And so now that we've had all this crazy recursion or crazy function that reaches out to all the other nodes into all the different paths, what I need to do is at first what I need to do is set my call my recursive function from the start, setting the visited at the start equal to true, because I do not want to actually come back to the start node because I'm not allowed to physically. So I need to set my visit at my start node equal to true because I know I'll never be able to come back. And then now I just breach out into all the different pathways using my function, which will keep calling itself for different parameters. So solve from the start node with a starting distance of 0. Why do I keep thinking it's solve? It's traverse. Okay. And then after I just output, and so what happens after is max dist will keep getting updated until it reaches its maximum value, which is the maximum length of the pathway. And so here I can just print out my max dist and then have an end line. So let's test if this works out. I should probably copy my code. Or copy my input. So we had 4, and that matches our sample output. Okay, I just realized I really didn't ask anyone if they had any questions with how I approached it. So, really quick, does anyone have any questions with how I took down this question? Okay, if not, can someone at least acknowledge the fact that they can hear me? Oh, wait, can you repeat your question? I could not hear you.
Can you just really quickly go over your function?
My traverse?
Yeah.
Okay, so if I'm at my endpoint, my end city, which is where I want to reach, I update my maximum distance. And then I do nothing else because I can't go anywhere with that pathway because I've reached the endpoint. I've reached the last city. And otherwise, I need to breach out to all the other nodes in from the current city that I'm at right now. And then when I breach out to those nodes, I need to make sure that I can't come back. I can't come back to that next node in any other pathway because I'm only dealing with the pathway I'm working with right now. So what I'm doing first is I'm setting my visit array for my next city equal to true, so that I can't visit that next node ever in another pathway because in another pathway in this recursive call, because it can be done in another recursive call which gets you through another pathway to that next node. But when you're visiting this current city and you go to that next city, you want to make sure that with this current city, your next city recursive call, that you can't come back to your next city. Like you can't come back to that next city because you want to keep trying to go all the way to the end. You don't want to come back or loop around back to the next city. So visit next city equals true, and then I traverse, meaning I go and call my function for the next city, and then one more than the distance of the current city because I'm walking that path. And then now, after I've made that recursive call, I need to set visited at next city equal to false because I'm done with my recursive calls at this point up to my current node or current city. So I want to make visit next city false so that any other pathway that doesn't pass through into the recursive call that I've gotten to will be able to visit next city. So I flag next city visit array as false. Does that make sense?
Sure.
Is it just confusing why I make it true and then I make it false after, or what?
Yeah, it's kind of hard to visualize, that's all.
Okay, let's actually... That's a good point. Let's actually visualize this. Okay, so let's say I'm working with a current city.
Okay.
Kevin, did you want to say something?
I was going to think of it as the list of visited cities. After you visit, you go back and try a different route. So you just remove that from the list of the visits.
Yeah. All right, so let me just draw it like this. All right, so let's say I had this pathway and it went up like this. Okay, so I'm at some current node. And then I move on to the next node. Okay, now let's say, all right, so this current node got flagged as false because actually, let's not worry about that. So I move on to my next city, and then let's say I didn't do this. I didn't say visit next city equals true. Then if I went up here, and then I went through all my possible recursive calls. I went here, and then I went here. I'd be back at this end city. But I can't, by the rules of the question, I am not allowed to come back here. So instead, if I make this false, actually let's undo these changes. If I made this false, then call the recursive function, walk into this next city. Then if I do all the pathways here, I can't come into here because I'm blocked by this if statement if visited at the next city in the pathway. I can't come here. That's not allowed because my program stopped me because this was marked as not marked as false. It should be marked as true. I can't come back here in any way possible. Like, it stops you from coming here, and then so you won't make a mistake. Does that make more sense?
Yeah, and what's the difference between marking it in the for loop and marking it like in the beginning of the function when you arrive at the node?
I don't think actually there's. Yeah, that works too. I'm pretty sure there's no problem with that. Just make sure after you let's actually. All right, so where am I at here? Okay, so if let me get rid of this. And so I'm pretty sure if I do this, visited at Cur City. I'm not going to use next city. I have to use Cur City if I'm in my if I'm outside of the if else. Visit at Cur City equals true, and then after visit at Cur City equals false. This should work as well. Let's test it. Yeah. So if I flag my current city as true, then breach out to all the nodes, and then flag my current city as false inside the same function call, but after I call all the next nodes and everything, and I set to false, then it should work as well. Does this make more sense to you? Like using city as, yeah.
Thanks.
Yeah. Both are valid ways to do it. Okay. Any other questions? Okay, if not, then we'll move on to our last one, and then it'll be open to any other questions or ending it off for 2020. All right. Actually, before I do that, this will probably be too big for...
Then remove the comments.
Somehow it's not. It's probably very close. But no, I do want to keep the comments there just because a lot of people benefit from the explanations. At least I think they do. Or why else would I put comments in the first place, right? Alright. Last problem. And then I'll explain James and giant pile of homework. Alright, teleportation C2 problem 7. And over the break, if you guys are doing problems and you have questions, feel free to direct message me. Many people have, and it's always great to see that people are asking questions and want help, because I'm probably going to be free most of the winter break. Well, doing my stuff, I'm probably not going to go out or anything due to the situation. And yeah, so feel free to ask me questions anytime, as always. And we'll get started for this one. This one's, I think, a little easier. But I wanted to do it just because either not many people got to it because of time, or they couldn't get it. Okay, some people couldn't get it, some people didn't have time probably, but we'll go through it right now. Okay, so teleportation. Okay, so Yang will teleport very specific distances only in the direction of Sat's home. Wanting to make sure he doesn't end up on a wild goose chase, he wants you to tell him if it's possible to get to my house. within disclosed location. Except in this problem, it's enclosed as units. All right, so it'll give distances that Yang can teleport away from himself towards my house. And then finally, an integer saying the distance from my home to Yang's. And then on one line, I'll put an integer. I'll put 1 if he can come to my house, or 0 if he can't. For the sake of the coronavirus, I hope he doesn't, but it's always nice to have a friend around. So yeah. Okay, so this is a little more similar to a knapsack question, but we don't need to use a 2D array or anything like that. This is probably a simpler solution to just do it without using a 2D array. Okay, so the approach. Int main. Alright, so the maximum number of lines is 11. So let's just put our distances as 15. Int lines or distances? Let's go lines. 15. And then we need some sort of Boolean array holding the distance from his house to for every location. Actually, let me just write it and then I'll comment it. This should be a DP. Okay, lines representing a length of distance. Length of distance, that's not really... yeah, teleporting distance. That makes a lot more sense. Teleporting distances. And then this represents, can I get X units, or can Yang get X units away from his house? For X being every index. So the relationship we're going to use is something like dp of I is equal to true if dp of I minus some line length, I minus length is true. The reason this works is if I'm at some current spot, then I can get here if one of my teleporting distances gets me back, gets me from some valid position to my current position. So let's take in our input. So int t, take in t, and then each line. So for int I equals 0, I is less than t, I plus plus. Take in our line, cn lines of I. Then after int dist, or sats house. Cn sats house. Kind of uncomfortable, but it's okay. And then from here, I have to take in, I have to loop through all indices from 0 to sats house and checking if I can get to that distance from a teleport unit, from a teleport distance back to here. All right, this will make more sense once I write the code. All right, so for obviously I can get 0 units away from Yang's. Yang can get 0 units away from his house because that's just his house. So dp of 0 equals true. And then for int I equals 1, I is less than or equal to sats house, I plus plus. And then for here, I have to loop through all the distances, so, or all of the teleporting distances. So for int j equals 0, j is less than lines. Choose my changes. J is less than lines of no, j is less than t, j plus plus. And so what I'm going to do here is if dp, or no, if I can go lines of j units back and still be in a valid distance away from his Yang's house, because if so this means if I being the current index I'm checking in the distance array minus lines of j, so if I minus lines of j is greater than or equal to 0, because if it's less than 0 that means I'm in a negative, so I can't come from somewhere and reach with the distance of lines of j and reach my current position, because I can't start at a negative distance. So if I minus lines of j equals 0, then dp of I equals dp of I minus lines of j. And so after, what I want to do is that I'm just setting my dp of I equal to, so whether or not I can get here depends on whether or not I could get here from a previous location. And if it's true for any of the lines, then I can just leave. So if dp of I, then break. Because I don't want to be in this for loop anymore, because I don't want to make my dp of I potentially false, because I've already concluded that I can get here. And so my final answer is cout dp of Sat's house. And it's funny, it's crazy, not crazy, but it's funny how I print out a Boolean, right? dp of an index is a Boolean. But when you print out a Boolean, it's 1 or 0. It's either going to be 1 or 0. 1 being if it's true, 0 being if it's false. So if I just print out a Boolean, it'll work and print out 0 or 1 as the question requests you to. This is the previous, no, this is the current question. Okay. So no, I can't get to Sat's house. Let's make this 10, because you could get to Sat's house if your distance was 10. Paste. Okay, yeah, you could have gone to my house because you'd use the 4 and 6, or just use 5 2s, or any combination really.
Unspeakable.
Hi, David. Would you mind muting?
Yes.
All right, great. Then I'll just serve.
Sorry about that. I thought I was muted.
All right. So this is the last problem that I wanted to take up. Does anyone have any questions with how I approached it? Okay, if not, I'll paste it in chat and then also put it on GitHub. And then now I'll go over the problem that had a fake solution because the constraints were, as a troll, they passed if you had a very bashy solution. But it has to do with James and the giant pile of homework. Okay, so let's look at that. So, problem 5. Okay. Alright. So, what you need to do is, effectively what you're looking to do is take in an input and the input t, and then you're going to have a t by t array, or 2D array. Each being some cost in time for James to do his homework. And he needs to take one of each thing. So he needs to take one from each row. And all the columns that he takes from have to be different. That's the overall idea of this problem. You can read the problem, but that's essentially what it boils down to. So let's actually have a look. at the test case. So I'll show you how to do it, but I'm not actually going to go through the code because it's just a lot of implementation that if you know the method, I'm sure you can figure out the implementation. Plus, we're running out of time. So 41777 11413 23145 98199, and you're to output the minimum of the total things that you take. Okay, so the most solutions were recursion of some sort, and their time complexity was pretty big. But this solution that I'm going to present has an O of, since we're working with t, the time complexity of this solution will be O of t cubed. It involves something called the Hungarian algorithm. So the Hungarian algorithm is a really OP way to solve literally this type of problem, only this type of problem. Okay, so what we need to do is the steps is, so you have your array, and then you take step 1, take minimum of all, take minimum element in each row, value of each row, and subtract each row's elements by that value. Alright, so in practice what this is going to look like is, so I take 78416, the minimum element is 1, so what I'm going to do is knock down everything by 1. So 1 minus 1 is 0, 6 minus 1 is 5, 4 minus 1 is 3, 8 minus 1 is 7, 7 minus 1 is 6. Alright, and similar idea, we're going to keep knocking down. And we're going to knock down by 1 again because that's the lowest element. 3, 6, and then here we're going to knock down by 1 as well. 0, 3, 0, 2, and then the minimum element of these is also 1, so it's knocked down by 1, 1, 2, 0, 3, 4, and then same thing here, knocked down by 1 because the minimum element here is 1, 8, 7, 0, 8, 8. Okay, so now that we've completed the first step, the second step is do the same thing with columns. And so if you have a 0 already, then just choose the largest non-zero element. So our largest non-zero element in this column is a 1. So let's knock down by everything by 1. So 5, 2, 0 is still going to be 0, 0, and 7. And then here we're going to knock down by 2 because you have a 2 here and everything else is 0. So it's 5, 0, 0, 0, 5. Here we're going to knock down by 3, 0, 3, 0, 0, 0. And then here we're going to knock down by 3. So this becomes 0, 0, 0, 0, and 5. Then here we're going to knock down by 2. 6, 2, 0. Knocked down by 2 is 4 and 3. Okay, and so the last step is, or the last thing you have to do is try to cover take like imagine you had sticks of length 5, and you have to place them horizontally and vertically. If you can place to cover all the zeros, if you had to place 5 different sticks or more, then you can move on to the next step. If you can use less sticks and cover it, then you have to repeat this process of 3 steps again. And so I'm not sure about this one exactly. I think you can cover it at once. So if you use this, you cover this up. Okay, there's at least 2 in each column, which means we're probably going to have to... Yeah, there's at least 2 in each column and at least 2 in each row. So it's definitely going to need at least 5 coverings. And then after what you do, because you have to cover with at least 5 things, is after what you have to do. This is a very niche algorithm. I don't expect you to really use this very much. It's just like useful for this problem really. And like what you do after is you replace the ones that had zeros in it, and then out of those, you put the original values back. So you'd put like 4, 1, 7, 1, 1, 1, 4, 1, 3, and then out of those there will be exactly 1 configuration such that you're going to cover every row and every column using only 5 different picks, and that's going to be the optimal way to pick your numbers. It's a very weird way to solve this, but it's actually the best way to solve this. So I don't really expect you to take much from this, but you can search it up if you want to have another look at it again or see why it works, or possibly find implementation of it. But there's a lot of different steps to how I did it. It seems pretty obvious, but in practice, it's a little bit of work to implement. So that's how you do this problem properly. But obviously, these test cases that we actually had were completely trolled. They weren't even double digits. So I feel sorry for you guys that were attempted, that were going to attempt it, but you got intimidated. And yeah, so that's everything I wanted to cover this week. Does anyone have any thing that they want to touch on right now, or like that can be solved in a few minutes, hopefully? Okay, if not, no worries. That's pretty much everything I had for this week. It was a very, very long week with a lot of content, but I hope we've taken up like the hardest problems. And feel free to send me any questions that you have over the Christmas break. I'll probably be replying to you very quickly. And I hope that you have a great holiday, and make sure to do some programming too. So have a good week, everyone.